In this video, I'm going to show you how to solve Project Lead the Way's step-by-step truss. In our class, we're going to call this one truss number 4, but this is the step-by-step truss problem for PLTW's POE. I'm going to start my truss by drawing out a free body diagram in proportion to the drawing represented on the PowerPoint. So here I am labeling out all the joints, labeling out my distances, even tossing in some other intermediate distances. I will need all of these distances later. Putting in my external forces. So these are my applied forces, a force at B, force at E, and a force at D. And then sketching in my reaction forces. I have a pin joint at A, so I have 2 reaction forces here. I have a roller joint at C, so 1 reaction force there. Next, I'm going to start to create a table. And in this table, I'll reference it later, but I use this to keep track of all of my external forces and their directions. So I'll plug in what I know right now: force at B, force at D, and force at E. And now I know my 3 unknowns are RAX, RAY, and RCY. I'm going to start with my moment equation, and I'm going to select point A as my pivot point. That's going to eliminate 2 unknowns, RAX and RAY. So I'm really only solving for 1 unknown, RCY. I need to check which moments are creating a negative moment. So that's the 3 downward forces. They're creating a counterclockwise rotation, a clockwise rotation, which is a negative moment. And then I just substitute and solve for all of my moments. So take my forces times the distance from my pivot point A. It's the distance perpendicular. And here I'm just solving my math. So just following through. And now I'll have RCY essentially being equal to 775 foot-pounds divided by 10 on both sides, and I have RCY as 775 pounds. Since it's positive, that's going to be going up. The sense is up. I'll now use some of my forces in my X and some of my forces in the Y equation to solve for RAX and RAY. In the X direction, I only have the force RAX, so that was easy. In the Y direction, I have a number though. RAY, force at B, force at D, and the force at E, plus I have RCY, which I just solved for. So I don't know RAY, but I do know all those external forces. I'm dropping the units here just in the interest of time. And I do know RCY, which is positive. It's up 775 pounds. So I can solve for RAY. And my math says that's 975 pounds up. Because I have a positive force there, it's going to be in the up direction. Now I'm just going to do a little planning ahead. I am going to start making another table for my internal forces. And so I list these out in alphabetical order just to keep track of it, keep students all on the same page. And I should have 7 member forces. And I will just use this to fill out as I go along with my truss. To begin solving for our internal forces, I'm going to use the method of joints, which is a system of equations that allows us to work our way around the truss and solve for each member at each joint. I need to start by selecting a joint, and I'm going to pick joint A just because it's the first one over there. It has two known forces, RAX, RAY, and two unknown forces, AB and AD. So I label them out in a free body diagram, and I do not include any direction for AB or AD. And then I'm going to use my sum of forces in the X, my sum of forces in the Y. Just going to label out the whole equation. So in the X I have RAX, AB, and the quantity ADX, the X component of AD. In the Y I have RAY and ADY. So I have one known and one unknown there. I'm going to put in my one known, 975 up, positive 975. That gives me ADY is 975, negative 975, or 975 down. Redraw that component force down, which means if that's down, then the sense of AD needs to be down as well, or down and to the left. So that means ADX is going to be going to the left. This is a 45-45, 90 right triangle. So without any math, I can just know that the sides of the triangle are the same. So I have 975 to the left, or negative. Plug that into some of my forces in the X equation. And now I find that AB is equal to positive 975. So at joint A, I'm going to note that AB is going to the right, positive. AD is going down to the left. I've made those adjustments on my free body diagram. And here I'm solving for AD, just using some Pythagorean theorem. And I get AD to be about 1379 pounds. I know that AD is going down. So here I'm just putting in my forces into my table, and I need to note whether they're in tension or compression. Well, I noted which direction each one was going, and when AD is going towards the joint, that's going to be compression. When AB is going away from the joint, that's going to be tension. So now I'll note both tension and compression for both of those. Moving on to our next joint, I'm going to select joint C, which has my other known reaction force, RCY. I have two unknowns here, BC and CE. I'm going to sum for my forces in the X, sum for my forces in the Y. Just list out what my X forces are, BC and CEX. List out my Y forces, RCY and CEY. I have only one unknown, one known there. So solve for that. CEY is going to be negative 775. That means that CEY is going down. Its sense is down, which means that CE's sense is going to be down and to the right. And that CEX then has to be going to the right. Since I have a 45-45, 90 triangle, I can just assume that CEX is going to be the same magnitude as CEY, or 775. And if I could solve for CE using Pythagorean theorem, I'm going to come up with about 1096 pounds. And that's down and to the right. I'm going to note that on my free body diagram. Now I plug in CEX, positive 775 going to the right, which gives me BC as negative 775 going to the left. So I note and update this on my free body diagram. I plug in BC and CE on my chart, noting that BC pulling away from the joint is in tension, and that CE going towards the joint is in compression. I then move on to my next joint. For this one, I'm going to choose joint E. At joint E, I'm going to have a few new knowns. I know that my force at point E, I now know CE, I just solved for that, but I do not know DE or BE. So I'm going to plug in that CE is in compression. Compression is going towards the joint. Note that I'm drawing that the opposite direction that I just used in the previous slide, basically. So I'm going to solve for my forces in the X, solve for my forces in the Y. I have a number of forces in the X in this one. two component forces for BE and CE. For my forces in the Y, I also have CEY and BEY, so two component forces, but I know one of those. So I'm going to start with Y again. Negative 500 for the external force, positive 775 because CE is going up, up and to the left, which means that BEY is negative 275. It's going down, which means that BE is going to be going down and to the left, and BEX is going to be going to the left. I'm going to use a different method here. I'm going to use a ratio. So my ratio of feet, 3 feet to 2 feet, is going to be the same as my ratio of 275 for BEY over BEX, which I'm going to solve and get 183.33 pounds going to the left because of sense. I can then solve for BE by using the Pythagorean theorem, squaring my values, taking the square root, and I get about 330.5 pounds. That's going to be down and to the left, which means that member is going to be in tension. I can then plug in CEX into both BEX and CEX into this equation here and solve for D, and I end up with DE being 958 pounds. Since it's 958 pounds and it's positive, it's going to be going to the right, which is going towards the joint. So when I plug it into my table here, I will note that that is in compression. The final joint that I'm going to select is joint D. I could select joint D or B, doesn't really matter. I'm choosing D here. I know that my external force, I know a number of these forces. So here I have AD. I solve for that one. That's going to be in compression. I have DE. I also solve for that one being in compression. So I draw those towards the joint. I don't know BD, so I leave that unlabeled. I'm going to sum for my forces in the Y just because I have fewer Y components. So I have the force D, ADY, and BDY. Sub my values, so negative 1,000 pounds for 1,000 pounds down, 975 pounds for ADY up and to the right, which means that BDY is going to be just 25 pounds. But 25 pounds is positive, it's going to be going up. It senses up, which means that BD is going to be going up and to the left, which means that BDX is going to the left. So this is all just sense of our moments or of our vectors adding up. I'm going to use that ratio, or I'm going to use trig here for this one, finding the angle. So inverse tangent of 3 over 2 for opposite over adjacent. I end up with 56.3. I'm doing sine of 56.3 to represent my opposite over hypotenuse, opposite being BDY, hypotenuse being BD. Rearrange my equation, plug in my values here, and I have BD is going to be equal to about 30 pounds. So it's 30 pounds up and to the left, so that means this is in compression as well since it's going towards the joint. I then note that on my chart, noting in compression, and there's just one last thing to do. The final step of my truss is to finally just redraw it and label out all the forces involved. So I put my points, I mark my joints with the letters, start with my reaction forces, labeling them in the correct direction. Use my applied forces here, the given forces at the beginning, labeling them in the correct directions. And then I'm going to come back with my internal forces, and now I'm referencing my table, and I'm drawing the ones that are in tension, I'm drawing away from the joint, and the ones that are in compression, I'm drawing towards the joint. So I'm just going through and filling in each, kind of combining all of my individual free body diagrams, and then I'm going to go ahead and fill in my values. I'm dropping the pounds off of most of the internal forces just because I don't have enough space. And now I'm filling in all my forces, and this is my representative of my full truss, and I can compare this to what I get for MD solids, and it should look exactly the same. Hope you guys found this useful. Can use it in your classroom, can use it to play over and over again to hopefully get a little bit better at understanding how to do a truss problem.